To be successful in high school math, you have to work hard and you have to understand some very basic things. You have to know how to add, subtract, multiply, divide, collect like terms, and the order of operations. Now, those 6 things you've heard, and they sound so easy, but they're the biggest mistakes my calculus students make, is not understanding addition, subtraction, multiplication, division. What do we mean by like terms and the order of operations? That right there, those 6 things, those are the keys to success in all of high school mathematics. Adding and subtracting, multiplying and dividing, I'm not going to waste your time on. You know how to do these things. You need to review them, especially with rational numbers. That's when you're multiplying and dividing fractions, or adding and subtracting fractions. Your calculator can get you through a lot of this if you know how to use it, but the more you understand it, the better. These two are where we're going to spend the bulk of our time on this video. What do we mean when we say collect like terms, and what do we mean by the order of operations? I don't know how many times you've heard the order of operations. It could be a lot. I learned it as please excuse my dear Aunt Sally. Many people have just learned it as PEMDAS. However you learn it, parentheses, I can't spell, so I just kind of fuddle it together, exponents, multiply, and divide in order, left to right. Those two go together. And then add, subtract in order, left to right. Now, I actually don't like PEMDAS as much as I like PIMA, because there is no such thing as division, and there is no such thing as subtraction. They're just different forms of multiplying or adding, respectively. So, parentheses, exponents, multiplication, addition. So let's take a really nasty example and walk through the order of operations. Take a look at this one. It looks really, really messy, but I promise you, if you just follow the order of operations, parentheses, exponents, multiplication, and division in order left to right, and then addition and subtraction in order left to right. The first thing you got to look for are parentheses. Parentheses is a bad name because it's really any kind of grouping. So I'm going to go through and I'm going to get the grouping. Well, we've got an exponent here. We've got this that's just being multiplied. Here's a big grouping. We'll do that. Got this here. Oh, got this big group here with little groups. Okay. And then that big group. All right, here we go. So, the first thing, 13 plus 9 plus negative 12 plus 1 minus negative 10 minus negative 6. That becomes negative 10 plus positive 6, so minus negative 4. The denominator looks real messy, but we do this and we get a 9 divided by. And now we've got to deal with this mess. I'm going to do this first and get a 1. 4 minus 3 is 1. 1 times anything is itself. So now I have this group. 16 minus 9 minus 8. And all that plus 12. All right, we keep going. Now it's all, well, we got to figure this out. So we got 16 minus 9, that's 7. 7 minus 8, negative 1. So we have 9 divided by negative 1. All right, so let's just clean all this up. So 9 divided by negative 1, add that to 12. Over here we have 13 plus 9, which is 22. Negative 12 plus 1, that's minus 11, plus 4. And now we've got 11 plus 4 over negative 9 plus 12. That ends up being 15 over 3, which is 5. Wow, that was a really complicated way to write 5 at the very beginning. But there you go. Now, I know I make that look easy, so I want you to pause the video and try this one on your own. If you pause the video, let's see what you came up with. The numerator and the denominator. A big fraction bar like this really means just you can do the top all at once and then do the bottom separately. So I'm just going to jump into the top. 2 cubed, that's 8. 8 plus 4, that gives me 12. Done with the top. Now I just got to figure out the bottom. Okay, so this is a negative 18 minus a 6 plus a negative 4 minus all of this, which looks like it's just negative 5 times negative 1 times negative 5. So that would be negative 25. You see how I got that? A negative times a negative is positive, times another negative is positive. 5 times 1 times 5. So here, let's see, I get negative 24 plus negative 4 minus negative 25. So that ends up being 12 divided by negative 28 plus 25. That ends up being 12 over negative 3, which is negative 4 is my final answer. If you got negative 4, then you did it correctly. Now, the other big skill that we need is the ability to collect like terms. Now, a lot of kids have told me math was easy until they started adding letters. That's when I got lost. Well, just treat these letters like they're numbers. The only difference is if you see a letter here, it's the same letter over here. That means they have to be the same number. So here's all this says right now. Take 3 and multiply it by x twice, subtract an x, and then subtract this whole mess in this parenthesis, which just happens to be a 7 minus 8 x's. All right, so I can do that. I got 3 times x. I'm going to subtract x. Well, I don't know what's going to happen there because order of operations says I have to multiply before I can subtract. So until I know what x is, I can't mess with that. Over here, I can subtract 7 and then subtract a negative 8x, which becomes a plus 8x. Good? Now again, order of operations, this has to happen first. So I'm just going to leave that as 3x squared. But a minus x minus 7, well, I don't know what x is yet, so I can't subtract 7. But I do have 8x's over here. So I can combine these like terms and end up getting a plus 7x. And then that minus 7 just comes along for the ride. So to make sure you see why this is a plus 7x, you have 8 x's here and you're taking away 1. Why can't we combine these terms here? Well, order of operations says this has to happen before you can do this. right? If I told you x was equal to 2, well, you would do 3 times 2 squared plus 7 times 2 minus 7. Well, that would be 3 times 4 plus 14 minus 7. See how we had to wait to see what we got here? That's 12 plus 14 plus minus 7. That ends up being 19, right? If x was equal to, I don't know, -3, we would have gotten a totally different answer here. It would have been 27 minus 21. So it all matters in the order of operations, which is why when we combine like terms, we have to make sure they're the same. Good?